Welcome everyone to this Premium Explainer Masterclass. Today, we're taking JWTs, JSON Web Tokens, and completely demystifying them. We're going to transform this topic from a confusing black box concept into a practical, enterprise-grade architecture that you can actually understand and build yourself. Think of this as your ultimate instructor-led deep dive designed specifically for developers, architects, and really anyone gearing up for a high-stakes technical interview. So grab your notebooks because we are stripping away the magic and getting right down to first principles.
Here's our agenda for today. We'll start with why we actually need JWTs, break down the anatomy of a token, and trace the authentication flow. Then we'll dive into enterprise Spring Boot architecture, cover some critical security mistakes, and wrap up with a few handy memory tricks.
All right, Section 1, why we need JWTs and how we're leaving those heavy database lookups behind.
So let's just dive right in. Before we even think about looking at code or tokens, we've got to ask the fundamental question, right? What problem are we actually trying to solve in modern distributed systems? To really get the solution, you kind of have to feel the pain of the old way. In the traditional stateful model, your server stores session data. That means every single time a user clicks a button, the server has to hit the database to verify who they are. Imagine you've got 10,000 concurrent users. That is 10,000 database lookups per second just for authentication. It is a massive bottleneck. Your memory grows with your users, and scaling horizontally? Yeah, that becomes a total nightmare. Now contrast that with the stateless JWT approach. The token is verifiable without a database lookup. It's completely self-contained, which makes it incredibly scalable.
Think of it like this. If traditional sessions are like a security guard having to call headquarters every single time you want to enter a VIP room, a JWT is more like a smart concert wristband. When you first enter the festival, they check your ID. That's your one-time database lookup. Then, they basically laser engrave your entitlements onto a tamper-proof wristband. From that exact moment on, whether you go to the VIP lounge or grab a burger at the food court, the staff just scan the wristband. No phone calls to headquarters needed. The token itself carries all the trust and information locally.
Moving on to Section 2, the anatomy of a token. Let's break open this black box.
So what is this magic wristband actually made of? Let's dissect the JWT and see what's under the hood. A JWT is literally just a long string of characters separated by dots into 3 distinct parts, and they're all base64 URL encoded. First up, we've got the header. This simply tells the server how to read the token and specifies the signing algorithm, like HS256 or RS256. Second is the payload. This is the real meat of the token. It contains claims, which are basically just statements about the user. And third, the signature. This is the cryptographic seal that guarantees the token hasn't been messed with. And because the whole thing is just standard JSON and base64 encoded, it's totally portable across any programming language you want to use.
It's honestly fascinating to see this in practice. When you examine a typical decoded JWT, focus on that middle section, the payload. You'll see standard registered claims like sub, which stands for subject or user ID, and exp for the expiration timestamp. But you'll also notice custom private claims like role, admin. This specific data is exactly what your microservices will use to make instant authorization decisions.
Now, here is an absolutely crucial point, and honestly, you might want to write this down because it's a massive beginner mistake. JWTs are not encrypted by default. Remember that base64 encoding we just talked about? Literally anyone can decode that. You really have to think of a JWT as a sealed, transparent envelope. Anyone who gets their hands on the token can read the letter inside, but the wax seal on the back, the signature, that proves it came from a trusted sender and absolutely hasn't been altered.
All right, Section 3, the authentication flow. Let's look at Alice's banking journey.
Let's see how all this builds into a real functioning system. We're going to walk through this step by step, tracing the exact data flow of a token in a production banking scenario. Let's meet Alice. Step 1. Alice logs in with her standard username and password. Step 2. The central auth server does the heavy lifting. It checks the database, and if everything's valid, it builds and cryptographically signs a JWT. Step 3. That shiny new token is handed back to Alice's browser. Now here's where the magic happens. Step 4. Alice wants to check her account balance. She sends a request to the API server, attaching the JWT right in the authorization header. Step 5. The API server gets this request, and guess what? It doesn't call the database. It doesn't call the auth server. It simply validates the cryptographic signature locally, just using math. Because the signature checks out, it trusts the claims, sees Alice as a user, and returns her balance instantly.
Section 4. Enterprise Spring Boot Architecture. Take in microservices to scale.
Okay, let's scale this up.
How do massive companies, like Netflix running thousands of microservices, pull this off without just creating new bottlenecks? The secret sauce is RS-256 asymmetric signing. In a true enterprise environment, you definitely don't share a single secret key everywhere. Instead, your central auth server, maybe that's Keycloak or AWS Cognito, holds a private key. Only that auth server can create and sign tokens. But what about all those downstream microservices? They only get the public key. They can verify the signature, sure, but they cannot forge new tokens. This is brilliant because it means even if one microservice gets completely compromised, your entire system's authentication remains secure. There is absolutely zero single point of failure.
For those of you building in the Spring Boot trenches, you've got to see how beautifully simple this is to implement. In your application YAML file, you just point to a JWKS, that's a JSON Web Key Set, endpoint provided by your auth server. Spring Security just goes out, fetches, and caches those public keys. From then on, the JWT decoder automatically validates incoming tokens right behind the scenes. You literally don't have to write any manual crypto code. You just drop a pre-authorized annotation on your controller, check for the admin role, and Spring handles the whole shebang. It's clean, declarative, and entirely enterprise-ready.
Moving on to Section 5, Security and Common Mistakes. Let's do some whiteboard interview prep. All right, let's pivot to a high-stakes technical interview scenario. JWT is super easy to get started with, but it is dangerously easy to get wrong. If you're sitting in an architect interview, you might get asked this exact question. What is the alg equals none attack? It's a classic. The alg equals none attack exploits poorly configured JWT libraries. Basically, an attacker takes a perfectly valid token, changes the algorithm in the header to none, completely strips off the signature, and modifies the payload to give themselves admin privileges. If your server blindly accepts whatever algorithm the token claims to use, well, it's going to process this forged token as valid, because none requires no signature. How do you prevent it? You absolutely must explicitly whitelist your allowed algorithms in your parser. Never, ever allow none.
And bringing it back to our transparent envelope rule, this is exactly why that matters. Storing passwords, credit cards, or social security numbers inside a JWT payload is a catastrophic production mistake. Remember, it's only base 64 encoded, so anyone who intercepts that token instantly has your user's most sensitive data. Instead, you should only ever store safe, non-sensitive identifiers, things like user IDs, authorization roles, or tenant scoping info.
Finally, Section 6, Summary and Memory Tricks. Let's make this stick.
We've covered a ton of ground today. Let's wrap up this explainer with some rapid-fire mnemonics to make sure these concepts stick permanently. First up, HPS for the 3 parts of a token. Header tells you how to read it, payload tells you who it is about, and signature says, trust me. Perfect, right? Next, you need to memorize the 5 standard registered claims. SIEAI. That's sub for subject, is for issuer, X for expiration, IAT for issued ad, and AUD for audience. A really great way to remember this is the phrase, well, it's a bit of a quirky one, securely I every instant authorized. Actually, scratch that. It's easier if you just think, securely I every instant authorized. If you can rattle those off on a whiteboard, you are instantly going to separate yourself from the pack.
So we've completely opened the black box. You now understand that JWTs aren't magic at all. They're just elegant cryptographic tools that let us build massive, scalable, stateless systems without hammering our databases. So I want to leave you with this provocative challenge. Take a good look at the systems you're working on today. Where are you currently relying on heavy stateful session lookups? And how will you apply these first principles to refactor your current microservice authentication to be truly stateless? Take these concepts, apply them to your architecture, and start building better systems. Thanks so much for joining this explainer, and keep learning.